recording. The goal was to have a reconstruction like this from just a regular video, like not from a depth sensor, like from somebody recording their room with their phone and then using this process to come up with these 3D models. And we did a pretty good job with this process, and it doesn't look that amazing from here, like just looking at it in the viewport like this, but in VR it actually looked pretty reasonable. And I actually think I shared this video with you guys, but maybe I didn't. But somebody would... The project itself was about finding the position of these glass pieces, because normally you can't reconstruct glass at all. And so the guy I was working with was using audio to figure out where any kind of glass surfaces were. And it actually did a pretty good job. Like, these were all automatically placed, these planes. So it actually does a great job. But for the demo itself, we wanted to have as much of the room reconstructed with the state-of-the-art method as possible. And this process was pretty state-of-the-art. The baby itself was actually reconstructed with a different app that he was using. That was like a mobile app, kind of like It Sees 3D that we use on the iPad. But the problem was, well, there were a couple of problems. The main one being that apps that are for mobile devices that do reconstruction typically can't do anything but like individual objects, like this. It's really, really hard to do room reconstruction with just mobile apps. In fact, I don't think I've ever successfully done it. We tried doing it before using this process, and it just worked horribly. I'm guessing that some of it is, now that we know that it takes so long to do this reconstruction of the entire room, like if you add all the individual parts, it takes like at least a day. What I'm guessing is that these cloud-based services just throttle something so that they just give up on the reconstruction at some point. And room reconstruction is so hard that it throttles pretty early, so it just breaks. But anyway, the basic process that we went through to get this to work was first, let's see. The first thing that we did was record a video, so let's see, where did Justin actually put the video? It's called Justin. Okay, so he recorded some videos like this. This is not his video, this is mine. It might be this. Oh yeah, it's this. So he was recording videos like this. And at the time we thought that convolutions like this would help, like if you wave the camera around. We didn't find that it made much of a difference. But it's worth trying, I guess. If you have a lot of time, then it's probably fine to use convolutions, because then it might find more correspondences. But first he just takes a video like this with his phone. For his glass reconstruction, he actually had a separate process where he used the audio. He had two phones, I think, one that was shooting audio, the other that was just taking the video recording. And so that was a separate process. But just for the basic room reconstruction that we're doing now, you just need a phone video like this. And he took a few of these, but let's see, he took a bunch. Actually, this is from my old room. Justin, room 2. Yeah, so he tried taking some individual videos. The shower is actually a different scene, but he tried taking some individual videos of the window specifically, of the desk specifically, things like that. We found that it didn't make that much of a difference. But anyway, after you do this, you can go into Photoshop. You can, well, if you have Photoshop or one of these programs that can split things into frames installed, you can do right-click, open with Photoshop. And Photoshop can open videos, which I didn't know before. So it will open the video, and then you'll see the frames down here. And you can use this to export into frames. So I believe, I actually don't remember where this option was. Edits. Here it is. Export, render video. And then it will give you some options for resolution of each frame, how often you want it to export. So I actually did 15 frames per second because he was recording at 60 FPS, I think. And I figured, because of time constraints, I just used every fourth frame. But if you have a lot of time or a stronger CPU than an i9 9900K, then maybe you can use a higher frame rate. I just did 15 FPS and that was fine. So you can choose a folder and then hit render and it will spit out all the frames. So inside of, let's see, this is the room run. So it'll spit out all these frames. For the entire room, I believe I used these 4,000 frames. Let me see. Yeah, I was using these. So it'll spit out all of these frames. And then we can use this to do the reconstruction. And these are all 720p. So each individual image is actually pretty small. It's only 100 kilobytes, but there are a ton of them, so that's the thing. But I think the reconstruction takes a long time, even if the resolution were really bad, like 480p. So now that we split it into frames, I'll leave Photoshop open for now. You can go into Metashape, which used to be called Photoscan. So anytime you hear the term photoscanned, I think that, oh, they don't show anymore. But photoscanned assets that you see in like the Unreal or Unity store a lot of them were reconstructed with this program before, but then I think Google bought the name, and they made this app where you can take a video of like a document, and you can take a video of a document and then it will find the text on it. I think that's what it does. Anyway, inside Metashape, and we're just using Metashape standard, which is pretty nice because for an educational license it's like $60 per computer, which is pretty cheap for research work, at least if you're using NSF money, compared to not having an educational license where it's like 2,000 or something like that. So after you open this, you'll see this empty scene. You can go to workflow, add photos, and let me figure out where these are. Wait, room here. You can select all of these and do open, and then it will import all of them. I'm just showing the import process. Like, the reconstruction itself will take a long time, and I'm obviously not going to do it in real time, but I'm just, the importing process takes a while. I mean, it's pretty fast, so I'll just do this now just to show you what it's doing. So it'll do this. It will create this chunk, which is, I think chunk just refers to one scene or something like that. And you'll see all of the individual frames, but it'll say that they're not aligned, which is true. The alignment process is when they do the basic computer vision process of trying to figure out where one feature is in another camera's view. And they'll just do that for, I think they basically do it pairwise for every single camera. So it takes a long time. So once you import these, you can hit align photos, and that will go through the entire alignment process. And it has a lot of options. What I found was that when we were testing this, I found that there's actually a really big difference between these different accuracies. Medium accuracy is really, really sparse, and high is pretty dense. Like, the reconstruction that we ended up using, which is this was done with high. When we did it with medium, there were like barely any alignments, so it actually makes a big difference. And highest can take just a crazy long time, so you just kind of have to find a balance considering how much time you have, how long you're willing to let it run. I'm guessing that if you were to do it on highest, it would take like, I don't know, maybe at least twice the time. So for a single part of the reconstruction, like if you were to reconstruct only, I don't know, his bed and go through the entire texture mapping process, Each individual part of this scene I think took like 4 hours each. So, wait, not 4 hours. Was it 4 hours? I think it was more like 3 hours. I don't know, 3 to 4 hours or something like that. Highest would probably double that. That's my guess. But again, I'm not sure. I'm not exactly sure what these other options do. I don't remember what they mean specifically. It's just some limitations on how many features it decides to use to align the cameras and how many features it uses to decide depth and things like that. You can look up these parameters and figure out what they do. Guided image matching. I just enabled it because every online resource said that you should, and it seems to be a common, relatively recent method of doing reconstruction where it basically goes back and does another pass to make any minor corrections. At least from what I was seeing online, it's supposed to make the accuracy much better. So I just enabled it, and at least from what I was testing, it didn't make it take significantly longer. So I'll just enable it. And then when you do this, you can hit OK, and then it will start processing things. Let's see. I believe that this estimate was actually much smaller than how long it actually takes. So it says it'll take 5 minutes, but it takes longer for this part. So this part I think took like a half hour for this initial sparse reconstruction. And I'll cancel this because I have already processed it. When you do that part, it will give you this. And this looked like garbage, and at first we weren't sure that it was even working because this was just like garbage. But these are actually, these are just the tie points, which I think are the most accurate features. Like, these are the features that it actually used to align the cameras. But this is not the final step of the process. There's another step that involves going back and using these tie points to figure out the depth of other points. So to do that, there is build dense cloud. Ooh, do I want to do this now? Yeah, I'll do it now. Well, I'm not going to actually hit the button, but if you go to workflow build dense cloud, there's this option. So again, it has a quality option. Depth filtering I kept as aggressive. I think that depth filtering, I wasn't exactly sure what it was doing based on what online resources said. My guess is that it's like a prediction of how much variance in depth there is. For a room is basically an entire 3D model with a bunch of individual pieces, so it seems like it should have aggressive depth filtering because there are a lot of layers of depth in a fully 3D scene. I just kept these options as is. Point colors and point confidence are actually really, really useful, as we'll see in a second. And I'm not sure what reuse depth maps is, but maybe it helps make it not take as long. I'm not sure. Let's see. This part took quite a while, and I'm not going to start this because it was already finished, but it'll show you another progress bar. And this one I think was actually the opposite of the sparse cloud. The sparse cloud from before, it said it would only take 5 minutes, but it ends up taking a lot longer. This one says it's going to take a crazy long time. Like, it told us it was going to take 18 hours at first, but it ended up only taking like an hour or less. So what this will do, at first it won't look like it did anything. Also, by the way, at the top left here you can see how many cameras it aligned and stuff like that. So well, actually, I believe that what it initially shows you is this. So it shows you the sparse cloud, and then it shows you the predicted trajectory of all of the cameras that it used. So it found 2,500 out of 4,000 camera positions, which is pretty good actually. And if you zoom in, you can see which camera it used for which parts. It's actually a kind of cool visualization. I like it. You can kind of look around and see like the bed is over here. But this will actually, you won't be able to tell if this is right or not without the dense cloud. So anyway, after you do the build dense cloud part, you can hit this button here to show the dense cloud. And so this is the dense cloud, and as you can see, it's a lot better. It actually looks, it's not a mesh yet. Like if you zoom in, you'll see it's clearly just points, but when you zoom out far enough, it actually gives you a good idea of what the mesh should look like. And Justin didn't take a video of the back part of these quilts, so this obviously didn't reconstruct. The windows failed, which was as expected. It was one of the points of this research to try to figure out where the windows are, because state of the art can't handle it. And you're lagging. One thing is filter by confidence. The confidence was much worse actually before. Maybe it cropped it. Can you still hear me? Huh. Maybe I cropped these out. Maybe I have another scene that I can show. Justin. Oh, yeah, this was the one that I cropped. So, let's see. You can delete the points that are not competent. I just want to show you what that visualization looks like, because it's really, really useful. This is actually the only program that I've ever seen do that for reconstructions. So it's pretty handy. Where did I put this? Metashape, Justin, full room. I have some terrible naming conventions. Like, I should be ashamed of myself, but I'm not. Okay, so this was the full room, and this had a lot more points. And this is what I mean by confidence. So there were these really... This is what the reconstruction initially looked like. It was garbage. Well, it wasn't garbage. A lot of things that are actually surfaces looked good, but there was a lot of noise. Like I'm not sure why there was so much noise here, but there was. And the window had a lot of noise, which was kind of as expected, because you would expect that reflective surfaces cause trouble. The TV caused even weirder problems because it's reflective. It's not just a piece of glass. So the things that were reflecting off of the TV, it predicted that light to be coming from an object that was in front of the TV, like this. So we were at first really worried about this because, you know, it looks like it's just terrible. But Metashape is nice because it will let you filter by confidence. So you can do tools, dense cloud, filter by confidence. And I believe that I used 4 to crop out this. So you can see that this is way better. And it removed so much of that noise. And it also has another nice visualization, so I'm going to reset the filter. It has colored confidence, so you can see that all this red is the noise. And it was actually pretty good at detecting where the noise was. So I kind of just found out by playing around with it a little bit, but these red points were generally 4% or less confidence. So that's why I used 4%. Maybe for other reconstructions it would be a higher value, but I don't know. It's worth playing around with. So, and these are actually a lot of points. These make up, let's see, if I make the max for, and if I select, you can delete these in Metashape so that it doesn't, like MeshLab doesn't bother. Oh, here's the confidence interval. I didn't even notice the scale when I was doing this before. You can crop all of the really uncertain points so that when you reconstruct it in MeshLab eventually, it doesn't try to spend too much time on these, and you can just kind of delete them. So right now it's at 326,000 points, and I deleted them. Oh, okay, I was looking at the wrong one. The dense cloud is 17 million points, which is a lot. I deleted those, and now it's only 4 million. So – those are some big gains. considering how long MeshLab takes to do this part. So anyway, this is the Metashape part of the process. It's just getting this point cloud. Now Metashape does have an option for building the mesh itself, like doing the reconstruction, but when I did this, it was really, really bad. Like, I don't know what method they're using, but the resulting mesh was terrible, which is why I used MeshLab instead for this. Although, as a disclaimer, I didn't actually try the build mesh after removing those noisy points, but even so, it really did. I don't think I actually saved it, but it made even flat surfaces look really bad. Like the bed just was filled with balls, basically. Like somebody was hiding under the sheets. So I wouldn't recommend using Metashape for the reconstruction itself. But you can export the point cloud, so you can do export points, and it will export it as a PLY, which is the most useful one in our case because PLY is the only format for point clouds that will save colors. It'll save vertex colors and it will be compatible with a lot of programs. OBJs don't save vertex colors. They only save the materials, and the materials themselves have information about where they expect the texture to be. So you would export this as a PLY, and in MeshLab can read PLYs very quickly, which I don't think any other program that I've ever used can. So full room, this is the one that I want to use. So you can just kind of drag the PLY into MeshLab and it will put it in here. And MeshLab is still just points, and there are some options for visualizing the points, like you can change the point size and things like that. So it actually does look kind of meshy, even though it's not. And you actually need to do... MeshLab is kind of like Blender in that it gets acceleratingly slower the more points that you work with. Like Blender can't really deal with more than like 100,000 vertices at once. And MeshLab is actually kind of the same. So what I did was I actually split this mesh into pieces. So I reconstructed the desk separately from the crib, the TV, the window, and the bed. I think those are the different components that I split it into. And you can just do that in MeshLab if you want to, or you can do it in Blender. It's kind of just up to you. Like for example, you can use this vertex selection tool and do like this. I'm not sure how many points I actually decided to use. Shift to subtract. Let's see how many the bed is, because I split the bed into its own for some reason. I'm actually not sure that this part is necessary. It might be actually, I don't know. I think I split it into millions, or like 500,000 each or something like that. I also removed the floor because the floor is obviously not completely reconstructed. You can see in MeshLab how many vertices are selected here. But in any case, you can use, you can like delete parts of the mesh, and then you can keep doing that until you have the part that you want, or you can crop it in Blender. But you just have to make sure in Blender if you do it to export as PLY. I think I used MeshLab because it imports this many vertices much faster. But anyway, let me open one of the individual PLYs that I used. So, Justin Desk better. Those naming conventions, though. Here's my desk. And this is actually after the reconstruction, so I can remove the mesh here to show you what just the point cloud. So you can see these are all the points after I crop them. And then you need to do the reconstruction. The reconstruction, we actually talked in the 590 about different reconstruction methods, but in MeshLab, there are a couple of standard methods that they have here in filters, remeshing, and let's see. They have a couple of methods like ball pivot, which we talked about. VCG I think is a pretty bad method, but at least I've never seen it have good results, but that's me. I believe that VCG is specifically for closed surfaces, so it wouldn't work for rooms. And Poisson, I believe, is also for closed surfaces. Yeah, see, it says it's for watertight surfaces. So ball pivot's the only one that works with rooms. At least that's standard for MeshLab. So you can click ball pivot, and I do like that MeshLab actually cites the paper that this came from. That's pretty cool. But they have some parameters like the size of the ball and things like that. I actually just left these as default, and you can hit apply to get it to do it. And how long did this take? I think that this took like a half hour or so, maybe even longer, like a half hour to an hour per part of this for this part of the object. So yep, that's about 644,000 vertices. So you could imagine that much more complicated surfaces would take a long time. Although we were specifically trying to reconstruct the entire room in one go, so we actually had a kind of difficult reconstruction process. At least our goal was hard. Like the shower individually, for example, was a different scene, and this didn't take very long to reconstruct. It only took like, maybe the entire process took like an hour. So it really just depends on how complicated the room that you're trying to reconstruct is. But anyway, you can hit apply and it will do the reconstruction, and after it's done, it will create this. So you can see that it now has vertices, and they're not points anymore. And the reconstruction is reasonable. I mean, we were kind of surprised that it was able to get the colors that were on the screen. So that was kind of cool. Like you can obviously see he has Slack and some other Skype call or something. So the reconstruction wasn't bad, considering that in his video recording he actually didn't even record that much. Like he didn't bother to spend that much time under the desk or anything like that. So it's reasonable. And this is also a desk, which I think was the worst one. Now we had this problem. The reason that Blender comes into play is that we had a problem where okay, so MeshLab, with this mesh you can do export mesh as, and you can export as an OBJ, and MeshLab will also create the textures and things like that. I think it just does it. I don't think I had to do anything specific to get the texture to export. I don't think I did. I think it just exported those as is. The problem was that we found that MeshLab's texture mapping was actually really bad, and it left a bunch of these white surfaces here. Let me try to find... I'm not sure if I have the original ones. Oh, I may have... Actually, I have it on my YouTube channel. So I'll just show you this quickly, because it actually is a big deal. It was really, really noticeable in VR, at least. And it looked like the reconstruction was just really bad. So we had to fix this in Blender. But let me show you quickly what we were trying to fix. Sigasia Demo V1, this one. So... when do I look at the bed? The bed was the one that looked the worst by far. Okay, here it is. So let me just make this 1080p for a second. I don't know if you noticed this marbling here. the resolution might be really bad, but all of the surfaces had this weird marbling effect where it was almost like there were little pieces of white just scattered around the entire mesh, and I'm not sure why, I don't know if it's like a MeshLab thing, but it was always in curves like this. So it kind of looked like, I don't know, specks of vanilla or something inside of the mattress. And it was really noticeable for the bed and the desk. So it's almost like, I don't know, it's almost like a broken, I don't know, it's almost like MeshLab decided to use white instead of transparency. And for some reason, I couldn't fix it in Unreal. But this was noticeable in the desk too, although less noticeable because the surface is already white. But anyway, it was really noticeable in VR and we had to fix it. So this part we fixed in Blender by doing this. So this is the crib part. And I basically just went through the typical... Actually, what did I do? Let me think for a second. Okay, so MeshLab... I believe that MeshLab already had Vertex Colors as is. Or I think that it used Vertex Colors instead of a texture. And Unreal maybe just bred the Vertex Colors. I don't remember this exact part of the process. But it's not super important. In Blender I had to retexture map things correctly using the Vertex Colors. So initially, let me open a new Blender instance. Initially, where's Woman Poses? Oh, that's from our Ismar project. Probably should have named that something less sketchy. Justin Room. I'll use this for now. Oh god. What is this? I think this was from using BCG or one of the worst methods. Justin Bed. Why are my naming conventions so bad? Alright, so Justin Room Points I think is the right one. Not that I would know from the names. It's weird, as strict as I am with my naming conventions and code, my file naming conventions are terrible. Anyway, I just want to show the Vertex Colors. So, if in texture mode, it will show Vertex Colors. I think this was actually the reconstruction from before we filtered noise inside of Metashape. So, these are all Vertex Colors, and you can tell because inside of Blender, when you go into edit mode, you'll notice that there's no texture. These are all Vertex Colors. And I believe that Unreal did read the Vertex Colors, but they were really bad. So I think that I'm trying to remember this part. It's not important, I'm just trying to remember why. I think in Blender, okay, I think in Blender I used what Metashape exported. So Metashape exported the reconstructed FBX, and then Unreal couldn't read the Vertex Colors. So in Blender, what I initially did was I did the really basic UV mapping. I did like UV unwrap, just the most basic one or something like that. And then I used this option to bake it. And sorry, this one specifically, bake to vertex color. This is actually something that's not in Blender 2.8. So this time I actually didn't have a choice but to use 2.7. Bake to vertex color will, if you just do it like that, like if you just do the most basic vertex color baking, it will create a texture like this. And this is the texture that created all those white specks and marbling. I'm guessing that it was just being poisoned by nearby surfaces or something like that, or just a bad transparency filter. So I had to UV map it with Smart UV Project instead. So instead of doing the most basic UV mapping, which is what I did initially, I had to use Smart UV Project, which takes a lot longer. And I split the mesh up first. So Blender, like MeshLab, does not work well with reconstructions of really high vertex surfaces. So as per some advice online from a forum, I split the mesh into individual meshes that were less than 100,000 vertices each. So that Smart UV Project wouldn't take forever. And I actually found that less than 75,000 was kind of the sweet spot. 100,000 still takes quite a while with Smart UV Project, but 75,000 or less for some reason took way less time. I'm sure you can automate this process by a lot if you write a Python script or something. But anyway, I split it into these individual components, and then I did a UV unwrap Smart UV Project, which created a texture map for each of these surfaces. And there I removed that bleeding effect. Oh yeah, so so I created in Blender. I did. What does it initially look like? In Blender, I did new. I created a 4K texture, and then I went into edit mode. And initially, this will just be like a black texture with nothing on it. And yeah, in Blender 2.7, in this tab here, I did bake to Vertex Colors. I think that's all that I had to do. I created a material for it as well that had the same name as a texture, which actually ended up being a bad idea because Unreal doesn't let you have the same name for multiple things, even if they're different types of objects. Like if it's a texture and a material, it still complains if the names are the same. But anyway, yeah, I think I just did bake. And then it created this. And that was it. So the positions of these vertices these are all placed by Smart UV Project. Okay, so the process is you create the texture. So initially it doesn't have any texture. So you create a 4K texture over in this area. Then you do UV unwrap, Smart UV Project. I just use the default option. And it will then place all of these faces in the right place, like this. Well, not in the right place, but a place that's reasonable. Something that looks more reasonable than this really noisy texture here. And yeah, then I just hit bake here. I did bake to vertex color, bake, and it did this. And that's basically it. Then you can export the texture in Blender. You can do image, save as image, and then you can save it elsewhere. And that was it. How did I do what? Yeah, so I split it into little parts like this. I just went into edit mode, and initially it's one giant mesh, and you can just highlight part of it and then do P to separate, and I did selection just to create different parts that were smaller so that honestly, now that I know this process, you could probably avoid having to split it into individual parts of the room. I did that because the initial way that we were doing it required that when I was using MeshLab's Vertex Colors in Unreal. That was before I did Smart UV Project, because... Oh wait, never mind, sorry. The reason that I split it into like crib, bed, desk was because MeshLab's own ball pivot takes forever if you don't do that. And then you need to further split it so that Blender doesn't take forever. So, yeah. But once it's split like this, you can still export this entire thing to Unreal. Like you don't need to export these as separate parts. You just need the separate parts to make different materials and textures. So each one of these has a different texture. This has this one called rightmost top. This one has this one. And so I end up with a lot of these. I exported them to here. So for the crib, for example, I ended up with, I don't know where the FBXs are actually. Where are the FBXs? Crib. Oh wait, never mind. It's one FBX. Okay, so it's only one FBX, but there are a lot of textures. So if you export all of these things to one file, so I have all these 4K textures and the one mesh for the crib, and then I have a folder like this for each part of the room. You can import all of these to Unity or Unreal. And so in Unreal I have this folder that I call text for some reason, and all the subcomponents. And I have this one mesh like this. The meshes are not oriented correctly, which is kind of unfortunate. I think it's because MeshLab actually recenters them when it does the reconstruction. So if you can find a way around that, that would actually save a little bit of time. Like I kind of just roughly position these in the room. You can see that I kind of just used random positions that looked right. And they ended up being very close. And it was something that helped was that in the video I knew where exactly this desk was and where this was. So it wasn't that hard to get it to be in the right place. But anyway, you get in this folder one mesh with multiple materials and these textures, and for each of these materials, I don't know how Unity would handle this, but in Unreal it didn't immediately, did it link? I think it did link the textures actually automatically. As long as you import the textures first before the mesh, it will automatically link the texture. But initially, when you first do this, you'll just get this. It'll just be texture sample into base color and then nothing else, because this is the most basic thing. The problem obviously is that Unity and Unreal both set specular to be like 0.5 initially. So I set specular to be 0 so that it's not shiny. In Unreal you can do that by doing right click scalar parameter, which will create one of these just scalars, and you can edit the value here. In Unity it's just a slider. I made it two-sided because if you don't do that, then the problem is that I don't think that either Blender or MeshLab, I don't know who did that, but I don't think that the triangles are actually oriented the right way. So if you don't make it two-sided, it will, from certain angles the mesh will just appear, it'll be like invisible. In Unity, so Unity doesn't have this simple checkbox to do this, but in the asset store they actually had a two-sided material. I use it a lot. It's like a type of shader that you can just download. And I also use this divide slider for emissive color in Unreal so that they're not shaded by the engine. The reason for this is that when you do the reconstruction, the images that I got from the video that Justin took were already lit, right? Because he had natural lighting in his room when he took the video. So it doesn't make sense to have extra lighting from the engine itself. Because when you did the reconstruction, he already had lighting. He had his own lighting, so there's no need to have extra. So emissive color in Unreal it'll make it so that the texture, the material is not affected at all by lighting. It'll basically make it unlit, but I believe that it's different from just doing your typical unlit shading because it can also still cast shadows on other things. I think that's how it works. I don't remember the details exactly. The divide node, it makes it so that it's not as bright. So if you look here, you can see this is the original texture and it's really bright. And by dividing the emissiveness, you can make it a little bit dimmer. Let me actually show you. If I don't do this, the material is really, really bright. Actually, I think the desk was the best one to show this with. So this is basically exactly what the desk looked like when Justin took the video. If I don't do this divide thing, then the desk appears much, much brighter than in the video. Actually, it wasn't that bad, I guess. Huh. It wasn't that bad. Maybe it was just in VR it appeared really bright or something like that. It might have just been a change that I made for the video to try to make it not as obnoxious. But anyway, fun fact, I guess. You can divide the emissive color if you want to have this effect. So, yeah, I guess you didn't need to do that. I think maybe in VR it just appeared really obnoxious when you didn't do that. Or it just didn't look right or something like that. I don't remember exactly the motivation. But I think it looks okay now. At least it's as good as we can get with trying to do the reconstruction in 2 days. I didn't. So we agreed that it's not much of, like, it's fine to just create the room itself, like to just put a bunch of planes around. Because pretty much, okay, so in the video that Justin took, you'll notice that his walls are bare. Pretty much no reconstruction method ever can reconstruct walls that are completely bare because there are no features. So unless you're tracking the thing that's actually doing the reconstruction, like the phone, like if you put a Vive tracker on the phone or something, then there is no way to find camera correspondences on a bare surface like this. So we just ended up adding the walls ourselves. And, you know, being that the point of this paper was to reconstruct the windows themselves, it didn't seem dishonest or anything to just put walls here. No, but having paintings would. It's just that we didn't have time to go back and redo it. Like, I was editing the video seconds before the deadline. So I just didn't have time. But yeah, having like paintings and stuff on the wall would help a lot. The floor is actually not that bad in the original one. It's just that when it missed some parts, but the only reason it missed these was because Justin didn't record them. Like, he didn't focus on the floor at all when he was doing this because we only cared about the objects. So the floor itself actually wouldn't be that bad because there aren't that many big pieces of the floor that can be recorded without seeing one of the objects that it can use as a reference point. So, yeah, I think it's just because Justin didn't record this. Actually, this is probably just like the path that he was walking. So his camera, unless he pointed the camera at his feet, then it wouldn't have found this. So the floor was actually decent, but the walls just didn't reconstruct at all. They were incredibly noisy garbage. So, if you want to do the walls, the door was actually not that bad, because doors actually do have features. So if you want to do the wall, I would recommend putting paintings and things like that around. I think that Justin had like exactly one painting, but it was like a narrow strip on the wall. And he didn't really record it, so it didn't show up. Or he took it down for this recording. But yeah, the walls are pretty much just completely bare. I'd also reconstructed a lot of the outside, by the way. I don't know if you noticed that, but Metashape got a lot of the tree, which we were not expecting at all. It actually wasn't from this. This was actually the one reason that I think that we used his... I think that this was the one reason that we used his separate video. where is this? Metashape. It's not here. Metashape window. Star dots PSX. PSX, I guess, is the Photoscan file format. Oh, actually, okay, we had a couple of impressive things. So I also reconstructed my windows, which didn't make it into the paper, but, well, it didn't make it into the paper just because he didn't reconstruct my window, because I didn't have an audio source. But, where is Justin's window? I guess his window is not here, but I can show you the example with my window. So, in my apartment, I took a recording of my window, which has a parking lot outside. And, well, I had two windows. So I had the small window near my bathroom, and I was just recording the window itself. And as you can see, it actually got a lot of the nearby building and the path that was in front of my apartment. So that, we were actually we were pretty impressed with that. And if you filter by confidence, you can get rid of a lot of this garbage in the middle. The building itself, you can see, is actually pretty confident, so that was cool. And I had this bigger window in my living room that I did the reconstruction from, and it also, we were able to reconstruct part of the cars outside, which wasn't even the point of the project. It was just kind of a fun thing while I was testing these different apps. So I had this big window, and one of the windows was open and one of them was closed. And yeah, you can see it got a lot of the cars, the bushes, some of the big tree outside, things like that. So yeah, it's actually a pretty powerful program, I think.
And stuff into pieces and generate the textures for that, how that would create like multiple textures for a single.
Let's see. Can you repeat that? I was actually, I noticed that OBS wasn't actually recording your audio. I don't think it's worth recording your audio anyway, so it's fine. Yes. It doesn't. They're separate materials. So for the bed, for example, or let me use the crib example because I have that open in Blender. Unreal has a different material for each part, and Unity would do that too, because you can have multiple materials for the same object. And in Unreal, you have this cool feature where you can highlight the specific part that it's texturing. So you can see that it has a different material for each part, which is also the case in, well, it's not the case in Blender. So Blender actually did split these up like this. And Unreal and Unity, so if you export this as an FBX, the FBX will have multiple materials, and it will have all of these parts inside of that one FBX file, but they're technically separated. Like the FBX, I don't actually know the FBX file format that well, but somewhere inside of there it does actually know that they're split up. Well, it already did this linking, but for the materials. So in Blender, each of these has a separate material. See? Over here. And I actually didn't even link the textures themselves here in Blender. If you did that, then I think for the sake of time, I did just add these textures into the material manually in Unreal. By default, it just had these white textures because in Blender I didn't actually link the textures that they were supposed to use. But in Blender, if you were to add the texture yourself, it would probably automatically do it in Unreal. And each part has its own material, and I have a texture for each part, and each one is UV mapped. Because of this baking process, the bake to vertex colors, the UV mapping is aligned with the texture that it's supposed to be using. So you can see that these are all the vertices, and they are perfectly aligned with the texture map itself. So as long as you're using the right texture on the right part of the mesh, I don't think you really need to worry about doing any of that manually. Just in Unity or Unreal, make sure to link the right texture. That's why I had this terrible naming convention where the material was named the texture with 1 added to the end. So crib top was this part, I think. So in Blender, I named the crib top. The texture was named crib top to... In Unreal, I think I renamed the material to crib top 1, and it's using the crib top texture. So in Unity or Unreal, whatever you decide to use, just make sure everything is in the right place. Like if I use one of the other textures from one of the other pieces, this would look completely wrong. What were your other follow-up questions? Yeah, I would try taking a video of a pretty small object, something really simple like a mug or something, and just trying out the process. And for now, I guess just worry about how to use Metashape. The splitting stuff up and retexturing in Blender, I think that's really a problem that's more limited to really complicated reconstruction, like of entire rooms, because this mesh had 4 million vertices before reconstruction, and even after being reconstructed, it still has a lot of faces. So my guess is that because Unity and Unreal both have a limit of like 8K textures, and it has millions of vertices, like at some point you just can't apply one texture to the entire room. It's like physically impossible to get the color that you need on the right face if there are more faces than there are pixels on the texture. Are you even there? Yeah, maybe. It shouldn't be too bad. Like I said, I think that each individual part, like this quadrant of the room, the crib, the desk, the bed, and the desk, or this other desk thing. I think that they each took like 4 hours each. Well, it took a lot longer than that to figure out how to do everything, but now that you know the process, I'm guessing that it should take less than 4 hours for something that's comparably complicated to one of these. Or remote into one of the lab computers. Well, why do you need TeamViewer? You're using remote desktop now. No, that's only the first time when you give yourself access through remote desktop. I'm gonna stop recording because this is not